Recording in progress.
Okay, good evening, everyone. So, as you might remember in the previous class, we talked about the concepts of money, about what you expect in this course, and again, there is a optional training for Python if you're interested. Then, later we talk about fiat money, currency, concepts of money, what makes money valuable, what could do transactions, definition of finance, ledger systems. There is some similarity and differences of Bitcoin traditional money. We also talk a little bit of history of Bitcoin, other systems. Also, we talk about what you are expecting in this course. And some general characteristics of Bitcoin. And hopefully, if you have time, we'll also talk a little bit of trading at the end of the semester. So, questions about the previous lecture? People over Zoom, whenever you have questions, you can just use your mic and raise your questions. So, let me show the Moodle again. So again, the course has several parts. I've designed 14 to 16 parts. So far, we just finished the first part, which was about the concept. As I said, when you go to communication tools, there is two sections. First is recorded session. So you have the recorded session for the previous one. And also for today, whenever it gets ready, I might update in 1 or 2 days. So next 1 or 2 days, you also see the updated video. Also, on top of the email, if you want to have like more convenient, faster communication, this is the classroom chat link. So this is over Telegram app. So in case you're interested, you can register in that application, and they could even chat. And it's just kind of less official, more convenient way of communications. Also, usually every part I assign 1 or 2 assignments. For first week, one of you actually, as I see, one of you just submitted the assignment. So also for this part that I'm going to start today, you also have 2 assignments. Usually this assignment doesn't take too much of time. Maybe each just might take about 30 minutes to answer. If you're more interested, you can just spend more time and just reviewing them, but usually they shouldn't take too much time. Again, your final grade has another major part, which is your reports, final reports or final project, which in the first one, you have to review 2 cryptocurrency projects and provide your insights. Maybe for each 1 or 2 pages enough. Then final project, which is up to the last week of this semester, it should be some innovation in blockchain cryptocurrency, and you need to make a quite bit, like maybe 5 to 10 pages of report. Sometimes during my sessions, I also provide some sample projects. If you want to pick my topics, you can just pick the one that are candidate for you guys. But you can also pick your topic too. The topic should be doable, and shouldn't be too small. And there should be an innovation attached to it. So that's it. So okay, so also last week, this time, every day equivalent to 1 week, but last part, I started talking about the concept and design of blockchain. So today we just go further, and hopefully we have time at the end of the class we do a very simple demo over a sample blockchain, and you do some transactions, you do mining, and you see how do they make sense. But before that experiment, we should talk about some jargon, some technical terms, and what you will see later on. But I assume when you do hands-on experience, those concepts and definitions or jargon makes a lot more sense. Okay, so blockchain.com is a major reporting platform. So when you go there, you see a lot of reports about major blockchain technologies like Bitcoin, Ethereum, Bitcoin Cash. I think they are the major, might be the oldest blockchain technologies. So let's just go to this website and just explore by ourselves to see what kind of information you might see there. So go to Explorer and pick Bitcoin on the left side. So you can just pick different projects if you're interested. So you might see some figures here. I mean, later on I explain more, but please, after class, spend a good amount of time play with this website. But I think the more intuitive one is price, which makes sense, the price of Bitcoin, and mempool size, blocks, and transactions. Let's look at the latest block. So 25 minutes ago, the last block in blockchain, in Bitcoin blockchain is just created. We don't know, the miner is unknown, but if you see 1 hour ago, maybe about 56 minutes ago, slush pool. Oh, thanks for letting me know. So, that's weird. So let me just close. I think I should first close the PowerPoint. Okay, so actually I click share, but I think that's still weird. So let's see. Okay, you can see. Okay, go to blockchain.com. Sorry, I shared, but since I think PowerPoint was open, it didn't change the page. So this is one of the major websites that you can get a lot of useful information about cryptocurrency-based blockchains. So as you see, the first one you see DSO, Stellar, Ethereum, Bitcoin. For today, I go to Explorer. And from left side, I just pick Bitcoin. So here you see so many figure information related to Bitcoin blockchain. And later I explain further. So, but price is very intuitive. So still the price is near 30K. But just for now, focus on the down left side. So as you see, 27 minutes ago, the latest Bitcoin block is created in its blockchain. The miner is unknown. Again, no worries. We talk about those. What does miners means? But 58 minutes ago, slush pool, which is the pool of several miners, created one block. So I opened the latest block. So some information, like I think timestamps might make sense for you. It just got one confirmation. I explained this one too. You see hash with several leading zeros. And what else you can see here? You see the difficulty, Merkle root, version of the blockchain, nonce, reward and fee. So the reward is 6.25. This is another name is Coinbase reward, is the reward that is offered to miners who mine this block. And fee is the optional, which sometimes, is optional, but usually people provide the fee to incentivize miners to basically mint or mine transactions within a block, because this just provides extra incentives for the miners. But again, no worries, we explain most of it for today. Even next session, I explain further. For example, what does this zero here even mean? What does hash means? So on and so forth. But just keep in mind, this is one of the very useful websites that you can get latest information about Bitcoin blockchain or the major blockchains that are listed in here. Okay, so let's talk about Byzantine general's problem or challenge. So it's very similar to the challenge that we have in the decentralized blockchain networks. So Byzantine king, it was an ancient empire in mostly Eastern Europe, decided to attack this castle. So usually it's better to attack from several sides, so you could have less casualties. But the catch is these generals need to collaborate with each other and attack at the same time. Or if they don't attack at the same time, they might have several casualties. But how they can trust each other? First of all, they are not fully trust each other. Also, when they want to communicate with each other, this general sent to this lazy general saying that I want to attack. This one might send information to this one and saying I want to attack. So ancient time, maybe they used pigeons. Maybe spies in the castle catch the pigeons and send some wrong information. So they couldn't attack at the same time. So in Byzantine general problem, the major issue is how they can trust the messages, right? And there is no centralized unit or intermediary that can verify the messages. So if you just consider the Bitcoin blockchain, so there's several miners and there's so many transactions. So each transaction is formatted within a message. And people just sending message to each other. Okay, I sent this amount of Bitcoin to this one. I received this amount of Bitcoin to that one. How people can trust each other? So this ancient Byzantine general problem and Bitcoin problem has a lot of similarities. So today we go inside the Bitcoin blockchain concept and see what Satoshi Nakamoto proposed in 2008 to solve the Byzantine general problem. Any question about this problem? I think it could be some similarity between this problem and the Bitcoin blockchain problem. There's a trust issue. How people can trust each other. So in Bitcoin, there's a public ledger that everybody trusts. And basically, the miners in the blockchain try to solve a puzzle, which we call it leading zero hash problem that they explain later on. So if the messages inside the blockchain are trusted, so you can make business. So, but let's see how Bitcoin blockchain answers to this Byzantine trust problem. So basically the blockchain, so each block consists of some information. Here I oversimplify it. So Hamid sent to Bitcoin to Mr. X, Mr. Y sent 2000 to Hamid, and Mr. Alpha sent 4 Bitcoins to James. And all of them consist of many our blockchain network. So there should be some association between blocks because I cannot send unlimited number of Bitcoins in my wallet. I should have limited number or like Bitcoin any cryptocurrency. So it should be some kind of association between this block that check if I really have that money and if I really send it to someone. These are the design features that we are going to cover today. So, and all of these features are a part of the answer for the Byzantine general problem. Public-private keys, Merkle tree, hash function, digital signature, proof of work, unspent transaction output, network of nodes, and transactions. So these are what we're going to cover today. Hopefully by the end of today, this makes a lot more sense for you. I think in the last time I talked about the reward. So there is a reward as for mining each block. So it used to instead of 50, now 6.25. So when I show you in the blockchain.com, the reward was 6.25 because we are after 220, and each each 2100K of blocks, the reward would be divided in half. So it's the incentive of the computers are working the network. So if they can solve the puzzle, they get these rewards. And on top of this, also they have optional fees that you guys pay. How this network is working. And even you might remember last time we talked about countries that has the major miners. Do you guys remember why there is no mining information in China? China was the leading country in mining, but suddenly got vanished. I have some news that why mining and Bitcoin or cryptocurrency in general was very important in China. So Chinese fellow could correct me. So I heard, I studied some news information saying that sending money out of China might have some a lot of paperwork regulations. So for Chinese investors, maybe if they convert their money to cryptocurrency, they can easily send everywhere around the world. They could make business, which may not, at that time, may not fit the government policy. So they try to ban cryptocurrency. But as you see, some countries like United States, Canada, Russia, Kazakhstan, Iran, Southern Africa, some African countries have a lot of mining facilities. I assume some countries like Iran, Russia, Kazakhstan, not Kazakhstan, maybe Russia, Iran, Southern America, might be they have some limitation of international businesses, so they cannot send and receive dollar easily because the US put some sanction on their banks. So they have a lot of incentive to mine, to do mining. On top of that, some countries have very cheap electricity. Might be Iceland is one of them, or they may not need that much of cooling facilities because in a very cold regions like Iceland, Russia. So it might be much cheaper if you want to mine northern Canada, northern Russia, or maybe Kazakhstan. Okay, let's talk about hash function. So basically, hash function allows you to convert every input to a unique output, and so lets you to save shorter amount of time. And basically, since this function converts every input to a unique output, it kind of works as a signature tool. So every time you put same data, you get the same hash. If you change your input, X here just means input. You have different hash. It's very easy to calculate, so computation efficient. And you cannot derive X from h of X. It's a one-way function. And you cannot find two X and Y, different X and Y, that their hash functions are same. And if you know X and a part of hash function, so here I'm showing h of X, you cannot derive X. Still, I don't say it's impossible, it's just infeasible. So it needs a lot of computing power and also a lot of talent. You need to spend a lot of time to break this function. Again, it may not be economical, because after spending too much of money, nobody trusts in your blockchain or cryptocurrency. You may not be worth of nothing. It's similar to Luna cryptocurrency that we talked last week. People lost their trust, so Luna is almost zero. So it used to be near $100 each. Now it's $0.0001. If people lose their trust, you lose your cryptocurrency. It doesn't worth to spend too much of money for something that you don't get that much of output. So this is hash function. So the algorithm is SHA-256. So I showed it h of X to just make it shorter. So as you see, either if an alien sends some Bitcoin to me 6 years ago, if I put a newspaper or my image, I have unique numbers. Each of them has lengths of 256 bits and either 0 or 1. So look, this information is sending like 1 Bitcoin from alien to me. Maybe if you write, it maybe takes less than 1 kilobyte. This newspaper might take 5 megabytes, or my picture might take like 2 or 3 megabytes. But then you can just shorten to a unique number. So this number represents all of this information. This number represents all of the newspaper information, and this number represents all of my picture information. So I can save a lot of space. So I don't need to spend too much of space. Just record all the information. I just record the hash numbers. Yeah, it's. I think it's your assignment 3. So you should explain what happened to Luna, and I think I already posted a video that explains one of the explains some of the reasons. But in your assignment, you can either use the video that I posted or just do your own research. But as you see, for Luna, actually, the reason that the drop happened is different, but overall, people lost their trust in that ecosystem. If people lose the trust, you won't. There is not that much of financial value to it, so it doesn't work to break the hash function. Okay, let's see what is inside each block. So we have 3 or 4 sections. First is block header. So block header has the previous block hash. So this rectangle is just a number. You don't have to put every information of the previous block into next block. The hash number is enough, because that hash number is a unique number represented to the previous block. Timestamp when that block created. Nonce, which is just a number I explain later on. Maker root hash, it just shows the relationship between transactions. Hash of the header and transaction, list of the transaction, for the who sent Bitcoin to whom, who received. So, and as you see, the hash of the block will be input for the next one. So the next one also has the hash of the previous block. Even in the last block, I have the hash of the previous header. So this is the way that we connect blocks to each other. So they calculate the hash of the previous header. It's just a number sent as one of the inputs to next block header. So generally speaking, block header as the version of the blockchain, previous block hash, maker root. No worries, I talk about maker root a little bit later on. Timestamp, difficulty target, and nonce. Okay, so have you ever heard of difficulty of mining or nonce before? Okay. Let's talk about maker tree. This is another jargon that you need to know. So look, I have 4 transactions. I'm showing L1, L2, L3, L4. Okay. So I calculate the hash of the L1. So this transaction might be saying that I'm sending like, let's say 5 Bitcoin to Dr. Han would be converted to just a number. The next transaction, maybe somebody sent alien send me some Bitcoin, would convert it to a number. This one converted to number. So I have 4 transactions. Now they converted to 4 unique numbers, right? Then I have these 2 unique numbers. I calculate their hash and I make just one number here. These two unique number with 256 digits converted to 1, and then these 2 would convert it to final top hash. So what's the point of it? So one part of blockchain is that you check all the transactions, so you don't want to see with fraud transaction. So instead of checking all of the transactions in the block, you just check the final hash. So even, let's say I have a copy of this transaction in another mining node, and somebody just changed this transaction. If they change this transaction, this hash would be changed, this hash would be changed, and this hash would be changed. So instead of checking, let's say, too many transactions, here we just see 4, but let's say in a block, we have 1,000 transactions. And you want to see if all of the transactions is valid because you have another copy somewhere else. Instead of checking all of those 1,000 transactions, you just check the final hash. If this is same, you can verify that copy. Let's say this hash is different. Then you check the next 2 hash. Let's say the right side is fine. You don't keep going. You check the left side that is not correct. Then you just go another level, and you finally might see L2 is not correct. Somebody did a fraud transaction. We changed this hash, and the final hash. So basically, instead of recording all the information, I can just record the hash numbers. And as you said, hash are just a relatively small number for the computers, and also very easy to calculate. So basically, hash function and matrix is just for verifying transactions in a more efficient way. So okay, let me show you another example. I wait here to use viewers to think about Merkle tree and hash function. So you see that there is a reason that we use hash function. We want we want to have higher security with less computations. And it's the reason we just make this tree that we call Merkle tree. And Merkle tree, you just check the toughest hash, then you just go down. If you see some discrepancy, you can just get to the roots easily. Question about hash functions and Merkle tree? I just wait 1 or 2 minutes here for everyone. So in case you have questions, I show another interesting example of hash function and Merkle tree. So we are later we talk about like 51% consensus. So there's thousands of people in the blockchain network that mine. Again, we explained the mining, but basically mining just means verifying transactions. So if 51% of networks saying this block is correct, everybody accepts it. And then with the Merkle tree and hash function, you can find what was the fraud transaction. Again, you might tell me that, let's say Russia bought, I think you can answer my question too. Is the question in the following slide. We are talking about 51% consensus, more than half. Let's say Russia just bought several supercomputers and they put all of them in the blockchain network. So they get the 51% computing power. So they can just change all of the transactions. But whatever they say correct, it should be correct through blockchain algorithm. Do you think Russia would do that? If they can? Yeah, nobody else would trust. It could be a Russian blockchain, but it won't be worldwide blockchain. Okay, let's look at another example. This is something similar will be used in some cloud services that they want to record your files, like OneDrive, Google Drive, what else? There's another Dropbox if you use. So let's assume 2 copies of our data. One copy is very safe and reliable, but another copy is hacked. And 1 megabyte out of 1,000 megabytes or 1 gigabyte, sorry, 1 million, 1 million megabyte or equivalent 1 terabyte data is affected. So 1 megabyte out of 1 million megabyte or 1 terabyte is hacked. How you find the problematic part of the data and fix? So you have one copy that for some reason you can trust, and one out of 1 million megabytes is hacked. So here, I think you already just transfer your files from one system to another system or flash drive. You must say it takes a lot of time. So Merkle tree and hash function could help us here. See, instead of just checking all the 1 terabyte drive, you can divide your hard drive. I mean, actually software does it, not you by hand. So look, they divided the hard drive into 6 different sections and created. They calculated the hash of each for the copy and also the write one, and they just go another level, create 1 hash out of these 2 hash, 1 hash out of these 2, 1 hash out of these 2, and finally that hash of all 6 parts together. So now they want to see which part of the your data is hacked or like affected by the virus. So they check the first level of hash. So this is the discrepancy. They go to next, they still see the discrepancy. They go to the next level. And out of these 3 nodes, 2 of them is correct. They don't have to check it. So, and again, the check is just checking a number. They don't have to go through all the data that they have. So they focus on this part. So this hash is different from the right version. They go to the next level. H3 is fine. H4 is affected. So maybe you can just check, instead of just deleting all the data and just copying, pasting again, they just change the last part. So as you see here, safety security is much faster than you just check everything. Again, I go back to the hash functions characteristics. Same data, same hash. You won't find 2x and y that the hash is equal. So if X and Y are different, the hash are different. So, and we know that hash function just change everything to the fixed length of numbers. So here, discrepancy comes because in the like part 4 of the hard drive, there is a discrepancy that happened by the virus. So let's say now, just keep in mind, so I want to check if a block is valid and verify the transactions. Instead of just checking all of the transactions, I just check the hash number. So if two hash numbers are same, all of the information is same. Let me wait 1 or 2 minutes in case you have questions. Yes? So the first level is the same. First level is discrepancy. Okay. You have to go 1 level. Okay, so then you go down. Yes, this is discrepancy. Next level, 2 out of 3 is fine. You don't have to go further. Just focus on the middle. So this is one innovation that lets people use, somehow fast communication or fast verification because of hash function and microteams. If you haven't had, blockchain could be much slower because in order to verify each block, they should check all the transactions 1 by 1. So it might take forever. So let's talk about public key and private key. So basically, these are just like some mathematical or computer science-based functions. So private key is kind of key or a password that I have on my own. I never broadcast it. But public key is another, let's say, another password kind of top or another key that I create from private key and I give it to people that I can trust. Okay, so for example here, Mr. Alien encrypt message with Pan's public key. So Alien has my public key and only one can read the messages because he has the private key that could decrypt the message. So I already sent let's say me and Mr. Alien wants to attack Earth. So we should kind of, we want to have some communication and we don't want anybody else could decrypt our information. So Alien has my public key. It would say, okay, I attack at 10 p.m., for example. So it would send me, and even if everybody on the Earth has the public key that already broadcasted, they cannot read the message. I'm the only one who can read the message. So one of the applications I'll talk later on, how to send money to each other. So I'm the only one who can read the send or receive message because they have the key that can open it. Again, we talk about, and these are created by the hash functions, somehow, not exactly. There's a little, some catch on it, but at the end, so just keep in mind, it's like sending secret message to each other is not necessary for blockchain. It has other applications, but again, the one who has private key and keep it for himself is the only one who can read the messages. So public key is for encryption, private key is for decryption, and also you can create public key from private key. So red one is a private key that can drive public key. And he can sign a message with his private key and send it to Mr. Alien in his spaceship. Mr. Alien can verify the message actually from him. This is another application of public and private key. I can send a message to Alien or someone else, and they can verify I'm the real sender of the message. these are the characteristics of public and private keys. Yes? Alien doesn't need to decrypt, you just verify. So encryption, so decryption is just for with private key. Public key can encrypt and also can verify. Next week, I'll show you some Python codes that you do something similar over Python, but hopefully, hopefully today we have some time. So I show you a demo that you don't have to do coding, but you do those signing, verifying, those kind of. So there is a verify function that you get a message, which is signed with somebody who has a private key, and with the public key, which is the green one, you can verify. So look at the hash, this hash function. So I said SHA-256 or hash function has 256 0-1 numbers. Just look at the combination, 2 raised to the power of 256. I don't know how big is it, but it should be very big. I think I already knew that 2 raised to the power of 64. That's, do you remember the chess story that somebody who created chess and asked a reward? So they asked the king to put a wheat on each block of chess. Chess has 64 blocks or squares, and they tried to put 1 wheat in the first one, 2 wheat on the second, 4, 6, 8 to the rest of 6 up to 64. And I think based on the ancient calculations, they should cultivate all the planets 4 times or 10 times to be able to give that amount of wheat to the person who created chess. So that was even just 2 raised to the power of 64. This is the 2 raised to the power of 256. Okay, so before going in depth into the relationship, just look at hash of each block. Look at the green part. Let me count 1, 2, 3, 4, 5, 6, 7, 9. I think it's 14 zeros. So there is some similarities between hash of each block. So we call it leading zero characteristics. So going back to this number, you see those leading zeros here too. And look at the nonce. Now I want to tell you a relationship between nonce at those leading zeros. So nonce has a each block has its own initial nonce, but in order to be accepted as a valid block or as a mined block, it should have a certain number of zeros. So each time miners get the information of the block, calculate the hash, and it should lead to a certain number of zeros. Let's say with this number, 4, 5, 6, 7, 8, 3, 9, 0, 2, plus this information, we have a hash function of 14 leading zeros. Inside the blockchain, it said if you have a hash function with 14 leading zeros, it would be as an accepted block. So now we get to the mining concept. This number, nobody knows what is the number. But how miners does, so they start from 1, 2, 3, 4, 5, they just keep adding numbers because they cannot know the relationship between nonce, this information, and having this amount of leading zeros. Maybe they have to do billions of try and error. They just keep adding, just finding some random numbers, add to the information, calculate the hash. If they get this amount of leading zeros, this block is accepted. So this is the blockchain mining puzzle. So when people talking about they bought very like expensive miners, they don't do, and these are for solving a puzzle. There is nothing just finding limited amount of zeros. How? If they have a very powerful mining facility, they can try those random nonce quicker, and hope they have more chance of finding this amount of living zeros, and so they can mint that block into blockchain. So let's say I use my laptop and I try to find the nonce. And Dr. Han in the computer science, they have a supercomputer. Maybe in 1 minute, I can try 1 million number, but Dr. Han can try 1 billion numbers. So she probably has more chance of finding the nonce. So they can find the nonce much quicker. I mean, maybe even sometimes there's chance for me to find it, but since I can try less numbers, I have less chance of finding the nonce to make these leading zeros, to take the hash with those leading zeros. And this is just the concept of mining. There's nothing just trying so many nonce, calculating the hash function until you find the accepted number of leading zeros. If you have more leading zeros, it's harder to find the correct hash function. So maybe you need to try more nonce. So as you see, I mean, those mining facilities, they are not, I mean, they are sophisticated design, but what they do is not too much difficult. They just try so many random numbers. Questions so far? Yes?
What is the purpose? I guess that's still on point. What is the purpose for mining?
So you verify the transaction, but who would verify it? So if somebody verifies, they get the reward. So there is a reward. So they call it Coinbase. So it's inside the Bitcoin algorithm. So if they can find a nonce with this amount of leading zeros, they get the reward. And on top of reward, they also have a fee. So again, when I go back to previous explanation, so the fees is optional money that people pay. So later I'll show you. I think last time I checked Coinbase, I think there's a fixed amount. Coinbase.com, not this Coinbase, is an exchange company. Let's talk about Binance company. But when you use decentralized exchange company, you can raise the fee. So you can pay more fee. So people mint your transaction inside their block because they have more incentives. They cannot put unlimited number of transactions. There is a cap. So if you put more fee, the miner would say, okay, it makes more sense to put that transaction into my block. So you have chance of getting verification much faster than others if you pay more. And later on, according to the blockchain Bitcoin algorithm, this Coinbase reward would be, I think, 2040. There would be no Coinbase reward. So everything is just based on fees. But also there is an algorithm inside Bitcoin blockchain that calculates how many leading zeros it requires based on how fast people can find this nonce. So if they expect, I checked the number, I think 21,000 blocks or something like that. So it should be mined within 2 weeks. If they can mine it faster, they increase number of leading zeros. If it takes too much time for the miners to find nonce, they reduce the number of leading zeros. These are just internal algorithms within Bitcoin blockchain. So these are what basically mining processes. Getting information of all transactions, putting them in a block, find a number that leads to some leading zeros, and create a block. Broadcast the create a block to hold the network. So this is the general hash function equation. So there's a SHA-256 algorithm. The inputs are timestamp, hash of the previous block, hash of the transactions, and nonce. These are the general inputs. Everything is known. The timestamp, you know when transaction happens, when the block created, previous block information, current transaction information, but they try to find nonce that lead to this amount of leading zeros. Is what miners do. And in each cryptocurrency blockchain, it's slightly different. In Bitcoin blockchain, we call it proof of work equation, not hash function. Okay, before we get into the next part, do you think what is the difference between traditional ledger and blockchain ledger? I mean, I think I trick you. So the answer is very easy. But what I show you so many complicated functions, it just looks very complicated. But the answer is publicly available ledger, which is decentralized. How people trust that ledger is based on at least 51% consensus. So there is so many miners, and everybody accept a block, it will be accepted. But there is a catch here. I wait 1 or 2 minutes here in case you have questions. Then I go to this issue that might happen. But again, no worries to ask this question. It's just first time you're hearing this topic, might be looks a little complicated, and you didn't have the hands-on experience yet, so it might be a little fuzzy. But I think after next week, these things should be super obvious for you guys. Let's talk about this issue. What happens if 2 miners, or generally 2 blocks mint at the same time, or mined at the same time? Both of them are correct. Let's everybody accept that. So what happens? Actually, again, I should talk about 51% consensus. So 51% of miners decide which one should be adopted and continue the blockchain, and which one should be left over. And they call it orphan block. I ran out of battery. Yeah, unfortunately, I ran out of battery. So, is there a reason? If you have never had a trading blockchain or never sent money to someone through Bitcoin or any cryptocurrency, you will see later. But if you already had, you might probably have seen confirmations. confirmation just related to this issue. Let's say I sent some money to Mousing, and it's needed in this block. So we get one confirmation, which means it's mined within a block, but we don't get further confirmation. It just means 51% of miners pick another branch, because these two blocks mine at the same time, and they believe they vote for this, and they just keep adding blocks on this blockchain. So when you send or receive money to someone, usually if you do to exchange companies, it might take a bit of time, but they're looking at it 2 to 6 confirmation. It just means your transactions is mined within a block, and 3 or 6 more blocks created after that. So the exchange company verify the transaction. So some blockchains are much faster, like ICP blockchain, or I can say Solana, but some of the Bitcoin and Ethereum takes more time because intrinsically the confirmation comes late. So you should wait. So I think last year, I think somehow in Ethereum might take 40 minutes to finally exchange company accept or verify your transaction. Because they are not sure that if your transaction is inside the block that has that is adopted with 51% of the miners. Some are in decentralized exchanges, which there is no exchange company, and you want to send money directly to each other. I have that experience. So sometimes I want to send money from cryptocurrency from one wallet address to another wallet address. Sometimes it didn't confirm because I was not lucky to be in the longest chain. Again, if you see, you can sometimes you cannot send money to someone and you have to review it. Don't blame your exchange company. It just means that all of the people within the blockchain didn't adopt the block that has your transaction information. But also there is another commentary which is fork. So somehow there's some updates in your blockchain. Majority of people accept that and keep working on it. So it will be the main chain. But there is some such chain that maybe 30% of miners adopt that and they believe their update is better. So here at this block, there's an update in the software and everybody vote for that. Let's say 30% said, no, we don't want the update, we want to keep block from here. And 70% said, no, we adopt the update and we want to keep working here. So they call it fork. Even here it happened. So maybe a portion of the miners said, we don't like the update, we want to have our own version of the blockchain, and they just keep working. So every transaction before that update or fork is accepted by all the forks or all the updates or all the miners. But if there's a transaction here, it's just accepted by this portion of miners. Here, by this portion of miners. So these are another concept that you might face later on, which is topic of your next assignment. So Bitcoin Cash and Ethereum Classic obviously refers to that forking. So some people accept the fork, some people didn't accept. So they make their own project. So Ethereum Classic, from one block of the Ethereum blockchain, they just said, no, we want to have our own version of the software. So they just keep doing mining their own branch, and same happen for Bitcoin Cash. So just do your own research, and this is your topic for your next assignment. So these are you guys in the maybe Starbucks working on this thing. So have you guys ever worked with the GitHub? I mean, I'd like to hand pro yeah, for sure. So something similar is in GitHub. So people share their codes over GitHub, and you guys can fork to their codes, adopt their codes, and change them. So, I mean, they're not exactly the same, but there's some similarity that you can just pick some people code or like software and just do your own changes on and make it your own. Which today we do. So for the demo blockchain, we fork on somebody's GitHub and take the codes of that demo blockchain, bring it in your PC and run it on your PC. So basically, you don't have to make the code. We just fork from another people's GitHub account, and just you can do your own changes, but for today we don't. So I just talk about difficulties. So as you see, like early on, it was much easier. Then it goes further. Difficulty of mining just gets harder and harder. And there's association between how fast computers can do hash function or what the hash rate speed. So there's an internal constraint inside the Bitcoin blockchain algorithm. So which every 2016 blocks should be mined or mined in 2 weeks. If it mined faster, they make leading zero more, so it's harder to mine. If it takes much more longer, they reduce number of leading zero. And there's an automatic function for that. So, and this equation was created by Satoshi Nakamoto, like about how many years ago? It was like 14 years ago, almost 14 years ago. Have you ever guys participated in the mining or heard any of your friends did mining? So they just use their own computer. I mean, these days it's almost impossible, but they use their own computer. They participate in the blockchain network and run some functions on their system to try to find the nonce. If they get nonce right now, they get 6.25 Bitcoin, which is equivalent to almost 200K. Early in the Bitcoin blockchain, the reward was 50 Bitcoin, which is equivalent to $1.5 million right now, if they kept it. But having said that, so early on, you can develop PC, sorry, CPU of the PC and join the mining network. This information might be updated, but for a PC, let's say 20 million hash per second is really doable. Later on, they figure out if they use GPUs, they could have much higher hash rates. With the GPU, 300 million hash per second is doable. Again, and this computer scientists and engineers work together and they created ASICs. It's a specific tools that the circuit designed just for hash mining. So with these tools, 60 hash per second is doable. Even with some tools, maybe the hash rate could be more. M is 10 raised to the power 6. Terahash rate 10 raised to the power 12. And now, if you check this website, which I showed now, look at the major miners. So one of them was founded in USA. They had 24.5% of hash rates and equivalent of 52.24 EHRS. So with your own PC, you cannot compete with that. Your chance of finding NAS is much less than. And also, these mining pools or these companies, these are basically factories that have several ASICs. Like that, very large buildings full of ASICs. So it's not doable to compete with them. Your chance is very low. And also, they are much more efficient in consuming power. So in terms of efficiency, it has the lowest one, and GPUs, power efficiency, and then ASICs. Mining companies, they have, let's say, 2,000 ASICs within one building or several buildings together. So another way that you still join and get a portion of the reward, which is 6.25 Bitcoin right now, join a pool. But what is pool? So people put their computing power together and join a group. The group might have, let's say, some ASICs in, let's say, Crush, some in your home, somebody like, let's say, in Canada, Russia. All of them can join a group of people. They call it a pool of miners, and they share risk and reward. They said, okay, we are 1,000 miners, and let's say I have 20 terahash rate. You have 100, and everyone has 50, and everyone maybe just have 1 terahash rate. So they proportionate the 6.25 based on how much computing power they put into the pool. Let's say 1,000 people join from around the world, and among them, my computer or my ASICs rigs, they call it the collection of ASICs. I have 1,000 of the total computing power that I'm just here. Maybe somebody has 10 terahash rate. I have just one, so 1 out of 1,000. So, and our group could find the NAS. So we get the Coinbase reward. So their reward is 6.25. So I took 1 out of 1,000. So my reward would be 0.00625 Bitcoin. So each Bitcoin is 30K. So this 4 cancel 5 times 3. Hopefully I don't make a mistake. $3K, so 7.5K or 7,500. You can see if I made any mistake, but it's no 30,000, so not K. Am I correct or hopefully I didn't make any mistake? So this would be my reward of putting 1 terahash rate into the group. It is really good if I made any mistake. So right now, I should consider all of things related to finance and economic engineering. So let's say if the amount of hardware and electricity, whatever I put here, in that time, if it's more than $7.5, doesn't make sense for me to join business. Let's say I'm in a part of the world that like this is very cheap. Maybe I spend $2 That makes a lot of sense to join this mining pool. Is why in some countries you might see a lot of hash rate there because the electricity is much cheaper. If there is much cheaper, they find the nuts much cheaper, meaning zero much cheaper, so they can mine the blocks much cheaper than other countries. That makes more sense to do those countries. So let's look at this link. For some reason, my PC is very slow. So. So this website doesn't show in my system for some reason. Could you get the website on your PC? I'm not sure why I cannot. Anyway, please check it later. So you can get very good information about the mining pools. Also, some of them provide some good information about what are the papers for you guys to join the pool. So you need to consider some major things. First of all, are you interested to join? Second, does it make sense economically to join the pool? And I've seen there is some incentive for renewable energy, even in Massachusetts or other part of the United States. So you need to do some accounting, financial calculation to see if it makes sense for you to join. But again, if you go back here, if I go to this figure here, looking at the United States figure, which is like a leading, is leading the mining. It seems for many, it made a lot of sense to do in the United States. Probably in the Massachusetts, we have very expensive electricity. I think it's about 10 times more than where I used to live in Michigan. So I don't think it makes sense to do mining in Massachusetts, but some part of the United States makes more sense. I think that there no more, but I heard we don't have any nuclear power plant here, so it might be one of the reasons it's very expensive. So yeah, so just you should, I mean, but as a practice, or if you are interested, you can just Google it. There's so many interesting websites that even let you to join the mining pool from your own PC. You can see, and they pay you a little. I mean, I think I did it a couple of days ago. I got like 2 cents, 1 cent. So it was a hobby for me, not just really making money. Okay, so let's just have a break for now, and please come back in 15-20 minutes if you want to have like drink, eat, or use the restroom. Please do that, and we keep continuing after the break. Okay, let's continue our discussion. So, by the way, I could get this figure and website over my cell phone. It seems in Clark it's just blocked. Maybe they don't like you to do mining here, but for any reason, so please go at home. Just go to that link, and you can see major mining pools around the world. Also, one Xuan Yang. Hopefully, I pronounce his name correctly. Is it Xuan Yang? Your name? Yes. Shibu. Oh, sorry. My bad. So he had a really good question. He was interested how to join one of the mining pools. One of the easiest one. Okay, I should. One of the easiest ones is cryptex.com. I send the link in the class chat room. So it's one of the easiest ones that you can, as a hobby, you can join one of the pool, and you just provide your computing power and join their pool, and probably they reward you. I mean, the reward is very negligible. And also just check if you are allowed to be in the United States or not. So if you are on the student visa, might be some restrictions, but other than that, even if I can't do it, I don't do it because it doesn't worth it for me. So just look at 1 terahash, 7.5 for 1 block. So let's assume I have just some mega hash rate, not even terahash. So if you divide it by 1,000, might would be like 1 cent at most a day. So doesn't worth that much, but as a hobby, so you can just sign up in this website. They ask you to download the software on your PC. And with that software, you can provide your computing power and join to that pool and get rewarded when they can mine a block. It's one of the easiest one. But if you Google it, there is so many other resources that even if you buy an A6, how to join to the pool. So there's so many good videos out there, but Cryptex is one of the easiest one. So you just need to download the software and just join the pool. So far we talk about two types of validation. One, how to validate a transaction is through signature. So with a private key, you can sign a message. So that message is sending some Bitcoin to someone. If somebody has your public key, they can verify the message. Also, we just talked about proof of work and how leading zeros let a miner to verify a block or mine a block. This is a general figure for creating how to create private key, public key, and Bitcoin address. So, and these are later we see the Python. So you have a function to create a private key. You derive public key from private key. So you can have several public key, all of them derived from just one private key. So you can make unlimited number of public key from a private key. With public key hash, you can basically derive Bitcoin address from public key. There is some calculations there, some double hashing and like elliptic curve multiplications functions, but this is just generally how blockchain, Bitcoin blockchain derive Bitcoin address, private key, and public keys. So in order to do the transaction, you need to expose your Bitcoin address and sometimes your public key. So although breaking that hash function is difficult, but for double safety, what people do, they usually exchange companies ask you, some of the majors, I think Bitcoin, Binance, there's another one. So those exchange companies usually change your public address or Bitcoin address or your public key because they want to provide another level of safety. So because if you want to send, let's say I want to send a Bitcoin to you guys. So I ask, provide me your Bitcoin address, and they're afraid that when you share your Bitcoin address, some people might try to break the code, break the hash. So as an extra countermeasure, they change their public address. So if you do through decentralized exchange company, decentralized exchanges, so usually your public address is usually the same or Bitcoin address is the same, but when you do through companies, exchange companies, sometimes they change your public address. So every day that you want to do a transaction, check the public address, because if you give a wrong address to someone, then you never get your coins. I think it depends on sometimes there is some attacks happen. I think one time Ethereum was somebody tried to hack Ethereum, or Hotbit exchange company. One time I think Coinbase, Binance, all of them had some experience of hacking. I think depends on the number of attacks. Maybe they change the public address more frequently, but don't think if you have an address, it will be same forever. So in case you have an entrepreneurship idea of like selling or receiving something using Bitcoin, just keep in mind, just check your address every day. And if you want to give it to someone, don't assume the address you gave them like 1 month ago is still the same. Your exchange company might change the public address. Because for them, driving Bitcoin address and public key is very easy. They can make unlimited number of them. So for extra level of security, they just every occasion they might change it. I don't know how frequently, but at least every time that you want to do transaction, just check your address and just send it to someone that you expect to receive the Bitcoin. These are Bitcoin network dictionary. Might be a little boring, but let me read from them. So wallet is basically address for sending, receiving coin, and public and private key has a major roles in it. Miners, they create blocks by finding the nonce numbers. Mining pools, collection of miners that share risk and reward. Mempool, collection of validated transactions that are not confirmed yet. So we have seen that some transaction might be valid. We check hash function signature, but they may not be confirmed. So you should wait to get several confirmation to be sure that you're in the longest chain. Fork and up, some of them are not very technical. Maybe Dr. Han don't like my definitions, but just because they are not that much computer science-based definitions, they're just my intuition. So fork updating the chain of block, full node, record hold the blockchain and can use for validation. Simply SPVs nodes, store blockchain headers only. Bitcoin wallet is an example of them. So basically, when you have a Bitcoin wallet, I mean, those Bitcoin wallet has the record of all the headers. They don't. So you download all of the headers of Bitcoin blockchain on your wallet. You don't have all the transaction information, just the headers. Proning nodes, prone validated transaction that are H. So assuming there's thousands of blocks and there are long time, 10 years ago, maybe you don't need to check that. So you have proning nodes that would say everything before that is validated. You don't need to check it anymore. We just check after some certain nodes. So they call it proning nodes. So there is some blames on Bitcoin blockchain. Some about people believe it spent too much of energy. So I think last year the energy that was spent on Bitcoin blockchain was more than country of Denmark or Argentina. And can anyone based on what I said so far, how those energy is spent? Why those? How Bitcoin blockchain spent that energy for what? Nonsense. Yes. You said what? Yes, computing processing. Yeah. So all of those energy was spent on computing process that you said, and the computing process just find the nonce. So they just search for the nonce by try and error to verify a block. So all of those energy just spent for just checking billions of nonce and calculating the hash function. Maybe look dumb, but it's how they spend that much of energy. So there is some new updates of this blockchain technology that has several goals. For example, expediting speed, reducing costs, reducing energy, or some other promises. For example, proof of stake, so which has higher speed, so you can do much more transaction than Bitcoin. But if you change proof of work just means finding nouns to proof of stake. We don't. If we have time at the end of semester, talk about proof of stake too. But Cardano is one example of that proof mechanism. So in Cardano, the miners doesn't find nouns. The internal transaction is different. So the internal transaction for validating the block of information is different. So proof of history, which Solana is one application of that technology, is much more faster than Bitcoin. Even it's faster than Visa card. So the proof of history provided much faster speed than proof of work. This could be a topic of your final project. So if you think you are interested in different technologies of verifying the blockchain, you can work on it. So these are the list of the proofs. You can just search about that, maybe write one page about that with an example. So just explain on your own words what does proof of stake means, and maybe you can talk a little bit of Cardano. So one page for one proof technology is enough. You can explain more, but it could be a project, and just one of you should pick this one. So it's based on first come, first served. So the first student who picked the topic can start from today and make this project his own. I provide some other topics if you want, but it could be one topic for your final project. And please find your topic by the end of next week to be able to finish by the end of semester, hopefully. We have a very quick semester. Let's talk about transaction format. So it's a little different from traditional transaction. So you have transaction ID, you have some inputs in each transaction, which the input has two sections. First, previous output transaction ID, the value of the money, and also signature. So you might remember I talked about how you can sign a message with a public key and then later verify it with a private key. So the signature, which is a output of a hash function, is an input of a transaction. The output is the money that you send and the address that you send the money. And the last part of a transaction is log time, which is when the transaction should happen. It should be at a time from now to something in future. So when you condition a time to a transaction, that transaction should happen at that time. It cannot happen sooner or later. It's different from checks. I think it shouldn't be. So if you, I think the bank shouldn't do that, but if you write a check and put a time and you put it in the bank, they cash it. They should wait by the time that you wrote on the check, but usually they cash it. Maybe they shouldn't. But in blockchain, if you put a time condition, the transaction won't happen before or after that time. And this is just a general figure. So let's look at the middle transaction. So inputs. So some of the inputs are from outputs of the first transaction. They come as inputs. They have some money. Output. With output, you send some coins to some addresses, which those addresses are basic inputs of the next transaction. Let's this example. So I have three inputs from different transaction IDs. So 2 Bitcoin from transaction ID 1000, 2 Bitcoin 1001, 6 Bitcoin from 1002. The outputs, 8 of them went to a vault address, and 1.9982 went to other one, and 0.002 just our fee for as an incentive for this transaction. So here, they want to make the transaction wants the transaction to be mined in the block quicker, so they put some optional fee. It's like tipping, so you tip miners. And the transaction would happen today at 10 p.m. So today's May 26th. So some transactions never go to anywhere. So as you see here, all of the inputs are spent, either went to an address or used as a fee. I don't have any unspent transactions, but it may not happen. So you might have some transaction that never go anywhere. So it just was input, but you didn't use it for sending to someone. So they just record it as an input. We call them unspent transactions. And actually, there is a database, it's a chain state, and it's the name of that database that has information of all of those transactions. So the fun fact, so chain state is a traditional database, it's not a Bitcoin, it's not a blockchain database. So for expediting processing, they use a traditional database inside the blockchain. And this view shows the amount of unspent transactions. So 80 million, which in comparison with all of the transactions is not the actually big number. So I put the reference, as you see, the reference is blockchain.com, and we would take this up block in the Block University. So I strongly recommend to spend a good amount of time in blockchain.com. Just try to discover. You get really good information. Now, some of the information there should make more sense, like unspent transactions, hash function, leading zeros. So let me go back to that website. Oh, you cannot see it. I go to Explorer, Bitcoin. Okay, the last block mined 18 a second. Let me open it. Do you see the leading zeros here? And it just have one confirmation. So we are not sure this block will be adopted or not because there's just one confirmation. We should wait 3 or 6 confirmation or 3 or 6 block added after this. So you kind of be sure that that block would be adopted as in the longest chain. So this is the blockchain ID. So 738,053. We don't know who mined, but it includes 755 transactions. You see the market route, difficulty, the version of number of weights. Let's see what other we talk about 6.25 Coinbase reward. So the people who mined it got this reward. And this is the total fee that they receive. Again, fee here is like a tipping your miners. And there's some other information here, but no worries. We talk about them later on. But at least right now, many of them make sense, like what timestamps, confirmation, hash. Anyway, this is a really good website, and the day by day, like they make more sense. Like today we talk about mempool size, transactions. Let me just open one transaction. Fees, value, comparing dollar. It's not confirmed yet. So why it's not confirmed? Because it's not inside the block that is mined. So it's confirmed because of private and public keys, but has not mined inside the block. And there is no basically block after it. Anyway, hopefully later it makes a lot more sense. But okay, for today we want to run 2 demos of blockchain. So this demo developed by Anders Brownworth. You don't have to do this installation, but since we work with this type of downloading, installing, working with GitHub, I put the steps here. So first, go to that link, install Node.js, and then install Git software. And then we go to the checking the GitHub. So first, I have Windows installer. So if you have Windows, probably I can help you more. I'm not a good one for helping you over Mac, but for Windows, just download the installer. Just press next, and just let every default would happen. Same for, since I already installed, I don't redo it here because my computer is kind of slow. Then install this this one. So I usually download 64-bit kit for Windows. So just download this one. And even for this one, just press next, and just do every default. I give you 5 or 10 minutes for you guys to download and install them. Then if you have issues, I can come on your PCs and help you with the installation. Please just do the first 2 steps. So could you guys be able to finish the installation? You're still need time. Finished? Okay. Okay, so what is the overall process? So with Node.js, we make a node in our local system that can host the blockchain, right? So if I make simplify, so let's say you want to read the information about Clark University, okay? So Clark website is hosted on a server, on a host. Here, the host is on your system, which you can run blockchain calculation on top of that host. So this demo is developed by Anders Brandworth. So if you copy the link on your browser, you can see all the codes that he made for his demo. He has two major demos that I used today. One is blockchain demo, the second public-private key demo. So basically for both of them, first we cloned his code on our local system. Clone is just, if I simplify it, we just copy his codes in our system. So how we do it? So after you've successfully installed the first two, go your command prompt, right click, and run as an administrator. This is, if you cannot find it, just search for CMD. So when you put CMD, on Mac, the equivalent is terminal. So here you pick run as administrator. So with the first command, I clone his files, his codes on my system. So I select this line, copy, right click and copy. Here, I'm my command prompt, right click, paste. So I already have the data on my system. It doesn't let me to allow it, but when you paste it, it takes a little bit of time. You download all the codes on your system. Or the technical term, you clone his GitHub on your system. After cloning, select the next command, which is cd blockchain demo. We go inside the folder that has all of his codes. So when you right click, so if you right click on your command prompt, you basically paste that command that I put in the PowerPoint. So as you see, I'm inside the blockchain demo. Here, type the next command or paste it, npm install. Okay, since I already installed, I'm not sure if, okay, okay, so I already had it in my folder. Maybe for you it's a little different, but basically, you installing a node inside that folder. Then type npm start. With npm start, now your host is running, and you can see the blockchain demo inside your system. Just copy this address, http localhost, 3000, and paste it here. First, I didn't change the code, so Andy just used his code. There's a YouTube video that he explained about his demo. I explained it today, so you don't have to watch, but later you can watch it. If you are not able to install it today, no worries. In the next page, I put the address for his website. He also hosting the demo on his own website. This is the link to his website. You can copy and paste it here. So look at this. The ad is andersronworth.com blockchain, but I also have it on my own host. So these are two exact equivalent, but just the demo is hosted on two different hosts. I didn't want to make your life difficult by letting you to download and install. I just can give you a link, but there is two reasons. Sometimes even his website is not running. So, but if you have it on your own PC, every time you can run, you're kind of independent. Second, later on we work with the concept of like Node.js and like cloning, forking. So I just want you guys to have just an easy experience. Anyway, so either you use this website or your own host system. Go to the first tab, which is hash. So you can put everything here. It's like, hello, this is blockchain cryptocurrency course. Hash is automatically created here. So change it to high, just one word. Still, you have a different hash, but the length of hash is same. If I go to, let's say, CNN.com, I just want to copy an article. I don't know what is this article, but just randomly click on a page. I just copy all of these paragraphs. Copy. Still, I have a different hash, but the length is the same. So the doesn't matter how big is your input, the output is different, but the length of numbers is same. In your spare time, you can just play with this, either your own instance or website, and just put different data. So this is a simple block. So it has 4 leading zeros. Let's say in the data, I put Hamid sent 2 BTC to Elon. Elon sent 100 BTC to Mr. Alien. So this is the first block with these nouns, and I want to mine it. As you see, the hash doesn't have any leading zero. When I mine it, the miner tries so many different nonce to be able to make 4 leading zeros. Let me change this. If I even change 2 to 5, just see what happens. The hash is totally different. So I told you, even if you change the smallest part of your input data, the hash will be different. So I'm just referring to Merkle tree concept, which if you want to find discrepancy between the two data, you just compare their hash. Because you are sure even a virus changed smallest parts of your data, you have a totally different hash. Now my hash doesn't have any leading zeros. Now I want to mine it with 4 leading zeros. So I click on mine. It found a nonce that has 4 leading zeros. So this block is mined and accepted in the blockchain. Questions so far? So these are just talking about the concept of hash and how mine a block. So here, the difficulty is just 4 zeros. Now you have a blockchain. So it just have 5 blocks. Let's say in the first one, I put Hamid sent 2 BTC to Mauzin. So if Mauzin, if you look at there, you see that when I change the first one, all the blocks after that block is not valid anymore. Also, look at the, if you look at them, there is no leading 0. The first one, I mean, if you look at the first block, I said block ID is 1, nonce 11, 13, 16. This is a transaction data. The previous hash is 0 because it's the first block. There is no block before that. So instead of, there is no hash, we just put zeros. And the current hash is this number. We want to mine it. Mining here just means finding a hash with 4 leading 0. When I click, it changed the nonce, and now there is 4 leading 0 in the hash, so its block is accepted and mined. So we have, if we change the first block, you have to mine all the remaining blocks too, because the hash of the first block would go is the input for the next block. So if the first one changed, the input of next block is changed, and we know if even there's a slight differences, the hash of the second block should be different. Since the first block has the input to the second block, look at the hash. This hash is not acceptable. I put the information here. Elon sent 1,000 BTC to Mr. Alien. I mine it. So one question here. I changed the information of second block. Why the first block is still green? Why I don't have to mine it again? Yes? Yes, you're right. It's immutable, but also the first block doesn't have any input from the second block. The information goes one way. Every block after this gets an input from here, and since the input here is changed, the hash of the next block is changed, and every hash after that is changed. So what does it mean? Let's say you have a blockchain with 1,000 blocks. If you hack the first one, if you find a hash function or any reason you have fraud transaction, you should mine all the remaining blocks. You cannot just hack one block and check some transaction. All of the chain after that would be invalid, because every part of the chain has input from the previous part. So if you change the first part, all the remaining would be changed. So I don't put anything for the following blocks, but I just mine one by one. Even there is no information, you have to mine them. Let me change the last block for your info. Or block number 4. Mrs. X sent 3 BTC to Mr. Y. So the information is changed. So the hash of the block is changed, and I don't have any leading zeros. If I mine it, look what happens. The blocks before that is still green because they don't have any inputs from block number 4, but number 5 is still red. You have to mine the next one too. So somehow hacking the previous blocks or transaction is not economical because you have to mine all the blocks after that. You need a lot of computing power. So the next tab is about distributed blockchain. We have 3 miners, peer A, peer B, peer C. And each of them has a copy of the block. Let's say that in block number 2, we are putting Elon sent 3 BTC to Amber. So it's valid in the first miner, but these are in these 2 they are not updated. And if you do a consensus, since these 2 has the majority in 3, so the first one wouldn't be valid anymore. And we assume the computing power is same in all the peers. Let's go to the tokens. So here is similar to the previous one, but instead of just typing all the transactions, so you have the list of transactions in each of the block. Let's say in the second one, I change this one to Parker to Dallas. It's a 6.5. I put mine. That block changed. And you have to change all of them in all of the peers in order to have your chain to be accepted. And the last one is about Coinbase. So Coinbase, again, is the amount of reward that is paid to the miner. So as you see, the first block, second block, third, and even fourth, Anders could be able to mine it, so he got all of the Coinbase rewards. But in the last block, Sophia won the mining competition, so she got 100 Coinbase rewards. I give you 5 or 6 minutes to play with these tabs, so you can experience different hash, play with the blocks, blockchain, distributed tokens, and Coinbase on your side. So then I go to the next demo. Yes, of course. With the GitHub that put this somewhere else. So reinstall it. Does it download or it didn't download to your pages? So so you essentially just accept just ask but worse, you want to say something. But that on the second at one bit the option asks you that you want to circle just one circle on okay, again, if you had difficulty in installation, you still can use this web address, which has the same demo, but on like a website over the internet. Okay, I'm showing the second demo. So you don't have to do first two because you already installed Node.js and you installed Git. And you just need to clone a new address on his GitHub. So just copy this address, git clone HTTPS GitHub, whatever, and open the command prompt. I already clone it, so it doesn't let me. So, but you can clone it again. You go to the address that you cloned, and then you write this command npm install, it just lets you to install npm within that folder, then you can host that folder. So again, just type npm start. This time, when you copy and paste this link on your browser, let's just paste it here. So you lead to the second demo. Still, there's a video file that he explained it here. And again, if you have difficulty in installation, here I put the one web address that give you the same demo. So copy this link in a browser and you can get exactly the same demo. But look, I have it on my own computer, PC host, but it's not accessible to over the third-party website. So if you be able to install your own system, you always have access to the demo. So I go to the key tab. So just see, with a private key, it just derives a public key. If I change my private key, let's just change the last two numbers. The public key would be changed instantly. It just shows you that public key is derived from private key. And also Bitcoin address will derive from public key. The second one is about signature. So here I put Hamid sent to BTC or Bitcoin to Elon. This is my private key, and I sign it here, and it gives me the signature. So as you see, signature is just basically a chain or a series of number and characters. So with the private key, I can sign, but how I can verify it with the public key? So Hamid sent 2 Bitcoin to Elon. This is the public key, and it's verified. It just shows you that you can sign a message with a private key, and somebody in the other side of the network can verify it if they just have your public key. So just keep in mind how public key and private key works. So you just have your private key. You shouldn't, you must not, you shouldn't share your private key, because if you have someone has your private key, they can sign all of the transaction for you, and that they just empty out your wallet. So never share your private key. Still, public key, people do not recommend to share your public key to everyone, but with private key, as you see here, you can create unlimited number of public keys. So you can derive as much as public key that you want from this private key. Now, in the transaction tab, we have more sophisticated one. So we are sending 25, here it said dollars, but let's say Bitcoin, to one address. We sign with the private key, we sign with the basically public key, we can verify our signature. And the last one is just a blockchain of all of those transactions. As you see, in each block, I have block ID, nonce number, which the nonce just lead to a leading zero hash. And I have a Coinbase value that's sent to an address. And also I have so many transactions. So each transaction is signed with a private key, and later you can verify with a public key. And basically, peer ABC have the exactly same copy of all of those blocks and transactions. I think some had difficulty installation of GIF and cloning that. So please set an appointment with me or TA in case you have issues. But it might be just a simple PC problem. Don't worry. If many people can do it and you follow exactly the same instruction, it might be just some security or some just simple installation issue in your system. So it shouldn't be a big problem. But again, for today, I gave you 2 links. So please spend a good amount of time playing with these demos, like change the message, change the hash, come to the blockchain, try to have some fraud transactions, for example, changing one of them and just see what happens. I think it's a good practice as a demo. So next week, I give you some, I teach you how to do something similar in Python. So again, just try to have a little review of Python. You don't have to be a Python programmer. So, and Python might look scary, but because we do everything from scratch and basics, probably you have less installation problem because you don't need to have interaction with like Node.js, GIF. So you do everything on your own system with just simple scripts. We just do something similar over Python. And I give you all the code, so you don't have to do coding. So, but you see all of those, how to create, how to sign, how to create public key, how to private key. And sometimes we try to basically have a fraud transactions. One of the fraud transactions we are going to do is overspending. Let's say you have 100 Bitcoin in your wallet, but you spend 300. And I show you how we can check on blockchain and find those fraud transactions. But anyway, I mean, so for this week, first try to solve your assignments. So it's a part of also your attendance. Even if you do everything wrong, but if you submit before the due date, you get attendance grade. Another thing that I want you guys to practice, try to install Node.js and also Git and try to clone. And what I'm saying that one simple recommendation that I can say, install everything as an administrator. Sometimes you have some authentication or some access issues. For example, if you don't install as administrator, you cannot copy and paste some files. So try to do everything as administrator. So even command prompt, when I open it, I just open as administrator. If you install Node.js, install for all the users, not just for the user that's logging to your system. And same for the Git. Let's say you have issues, just see me in the next office hours. If my office hours doesn't work for you, just send me an email. We try to find a common time that works for both of us, and you can come to my office. I see your PC. But again, no worries. If you cannot follow this installation, there's nothing wrong with you. Probably there is just a small issue in your PC. So don't need to have a lot of worries that why you couldn't follow it. Probably the issue is very simple. Anyway, I think I tried too much. It was too much for today, but thank you very much. So please get prepared for the next week, which we have some Python experiences. Thank you very much.
Thank you, Professor.
Thank you.